Hi guys, we're going to cover section 2 today. Lots more chemistry, lots more about chemical reactions. We're going to talk about balancing equations. When we get to that part, feel free to pause the video, feel free to rewind it, go over it again and again and again. It's brand new, it's a little complicated until it clicks, but it will definitely help you in high school, so pay attention to that, okay? All right, so let's look about how we write equations. You already know that the reactants are what you start with and the products are what you wind up with. But we use these formulas to represent the compounds that are changing. We know that a symbol is a 1 or 2 letter abbreviation of the element that is involved. You need to make sure and capitalize it. If it's 1 letter, it's always capitalized. If it's 2 letters, you only capitalize the first letter, and the second letter is always lowercase. You don't get to go back and forth on this, okay? It has to do with recognizing the formulas when they're written together, okay? Again, the formula is those letters, but it also includes these numbers because it's showing us the ratio of the elements that are occurring in each of these compounds. So you know that water is H2O. You've known that forever, okay? What that means is that in every single molecule of water, you have 2 hydrogen for every 1 oxygen, okay? And that's a big deal. We're going to talk about why and how we can't change that without changing the actual composition of it in a little bit later. The number that tells us that we have 2 hydrogen is called a subscript. It means it's below the line, okay? Those are the smaller numbers down there. We cannot change those again without changing the actual substance that we're looking at, okay? But then you notice these larger numbers, okay? These are called coefficients, and those have to do with balancing the equation, which we'll get to. The coefficient actually applies to the entire molecule that it's in front of. The subscript only applies to the element that it is next to. Okay, so it's not as widespreading. You can change the coefficient without changing the chemistry of the compound. You cannot change the subscript at all, okay? So let's see how these numbers work. What does this mean? How many atoms do we have of each element here? All right, so what this coefficient of 3 means is it means that I have 3 complete molecules of water, okay? So how many hydrogen do I have? How many oxygen do I have, okay? Well, if you can kind of picture having 3 complete hydrogen molecules, that would be 2 in one, 2 in another, and 2 in the third for a total of 6. So what I do, it's kind of like distribution. I'm actually going to multiply that coefficient to every element that I see there. Now we know that there's only 1 oxygen, and there's an imaginary subscript of 1. We don't have to write that. So it's like 3 times 1. So that tells me that I have 3 oxygen. Now, if I wrote it like this, okay, that means that subscript would only apply to the oxygen, not the entire compound. And that would be something totally different. I'm not even sure that exists. That would tell me that I had a compound with 2 hydrogen and 3 oxygen, which is not water, okay? All right, down here, we don't have a coefficient. So the 2 applies to the iron, so that tells me I have 2 iron, and the 3 applies to the oxygen, so I have 3 oxygen, okay? But now I have the same compound, I have a coefficient in front of it now. So I have 4 of these things, so I'm going to distribute it. So now that tells me I have 8 iron and 12 oxygen, because I have 4 complete molecules of that compound, okay? Same thing up here. This coefficient tells me I have 2 of these. So that gives me 4 hydrogen. That gives me 2 sulfur. And that gives me 8 oxygen. Okay? Now this last one's pretty complicated. This is a much more complex compound. What that means is when there's a parentheses, the subscript on the outside of it only applies to the parentheses itself. This is totally different than a coefficient, okay? There's no coefficient, so that means I have 1 of these molecules, but that molecule contains 3 barium and 2 of what's in the parentheses there. So it's kind of like reverse distribution, not reverse distribution, but from a different end. So this 2 is going to apply to that oxygen and that potassium, but not the barium. Okay, so this gives me a total of 3 barium because of that subscript. Gives me 2 phosphorus, and it gives me 8 oxygen. Okay. Pause, go back, look at this, because you got to be able to figure out how many atoms there are of each element in order to balance the equations. Okay. Before we get to that, let's talk about different types of chemical reactions. We have 4 main types. The first one is synthesis. That's when you synthesize something, you make something, you put it together. So a synthesis reaction takes 2 elements and chemically combines them. Okay. Decomposition is the opposite of that. If something is decomposing, it is breaking down. So the chemical bonds are actually being split apart. Okay. Then we have 2 types of replacement reactions, single and double. In a single, you've simply got a single element trading places. Okay, so the B and the C swaps spots. In a double, you've got 2 elements trading places. Okay, so that swaps places with that. Okay, if you look at page 549, it says that an example of a synthesis reaction is burning magnesium. So I'm going to do that for you guys because I can. There we go. I just have a tiny little strip of magnesium, and this magnesium is just a little piece of metal right there. It wants to react with the oxygen in the air, but it's not. When I burn it, it will though, okay? And so the magnesium and the oxygen are actually going to come together and synthesize together. Let's see. Just watch closely as I burn the magnesium. Hopefully this shows up all right. My eyes. Crazy, right? So that's not a typical burning reaction. That was a change in color, and it burned it. And now it is just ash. And now it's on my computer. All right, so moving on. We just have some chemical formulas, some written out reactions. This would be synthesis. That's what I just showed you, the magnesium and the oxygen coming together. Decomposition. This is hydrogen peroxide. Okay, H2O2 is hydrogen peroxide. If you break it apart, the decomposition of hydrogen peroxide, that's actually the chemical reaction that's happening when you see elephant toothpaste. Okay, single replacement. You can see the carbon and the oxygen are just trading places. And then double replacement. This is hydrochloric acid, which is, an acid. It's not necessarily safe. This is a really strong base. They're trading places and giving you 2 completely innocuous things, water and table salt. Okay, both of these substances would burn you. Neither of these do. Okay, they have 2 things traded places. I don't remember if I'm going to talk about this, so I'm going to talk about this right now. Okay. I think I will when I get to the balancing equation, so I'll just skip it if I'm jumping ahead to it. H2O, 2 hydrogen, 1 oxygen. H2O2, 2 hydrogen, 2 oxygen. If I stick a 2 next to that oxygen, I've completely changed the chemistry. Water, you need it to survive. Okay. You drink it to stay alive. Hydrogen peroxide, if you drink it, it's a poison. So by adding that extra oxygen to it, by putting that number there to indicate something else, you've created something totally different. Okay. So when it does come time to balance equations, don't stick them in the subscripts, only as a coefficient. All right, time to look at balancing equations. The reason we balance them is because the law of conservation of mass tells us that we need the same amount on both sides. We're not creating or destroying mass at all, okay? Those coefficients change the number of molecules, like I said. We can change those. We can never change the subscripts. And here comes that example of the water and the hydrogen peroxide, which I just told you. All right, let's go to this website. Take my pen off. There we go. If you guys pay attention to the website here, this is WikiHow for balancing chemical equations. it's kind of got some good pointers and some good diagrams on how to balance these things out. Okay, so this is just traditional balancing here. You write down your formula, your equation, but then it's asking you to total up everything you have on each side. So on this side, in my reactants, I have 3 carbon, 8 hydrogen, 2 oxygen. On the product side, I have only 1 carbon, only 2 hydrogen, and now I have 3 oxygen. So it's not balanced, okay? So we need to start playing with this. This recommends you hold the hydrogen and the oxygen to the last because they appear in so many different formulas. Deal with the elements that are there aside from hydrogen and oxygen, okay? So looking at the carbons, I've got 3 on this side and 1 on the other. So I'm going to put a large 3 coefficient in front of this entire compound. So now that means I have 3 carbon on this side, but it also changed the number of oxygen on this side. So 3 times 2 is 6, plus the 1 right here. Now I have 7. Okay, so my carbon is balanced, but my hydrogen and my oxygen is still out of balance. So I'm going to move on to the hydrogen. If I put a 4 in front of the H2O, that gives me the 8 hydrogen that I need to balance that side, okay? But it also changed the oxygen again. So in addition to the 6 right here, I have 4 more. So that 4 times the 1 right there gives me 4 for a total of 10 oxygen on this side. I only have 2 on this side, but maybe you can jump ahead and see what I need to do to this to make these numbers equal. Yes, I'm going to put a 5 in front of it, and now those are balanced, okay? So let's go back to the PowerPoint here, and let's do some of these, okay? So you want to take the time to write down what you have on each side. Okay, let me get my pen going again. All right, so on this side, I don't like that color. I'm going to go back to my yellow. Okay. I have 1 magnesium, and I have 2 oxygen. On this side, I have 1 magnesium, and I have 1 oxygen, okay? So it says to do the oxygen and hydrogen last, but our magnesium is already balanced, so I have to deal with the oxygen. So I'm going to put a 2 right there, but now that gives me 2 magnesium, but my oxygen is balanced, so that's good, okay? So I have to come back to this side and put a 2 in front of that one as well to make sure those are balanced. And that's it, now that's a balanced equation, okay? All right, let's look at the aluminum and oxygen one. I have 2 aluminum, and I have 3 oxygen. On this side, I have 1 aluminum, and I have 2 oxygen. Okay, I'm going to deal with the aluminum first. So I'm going to put a 2 right there. Okay, so that gives me 2. But now I have to deal with the oxygen. I've got a 3 on one side and a 2 on another. And just like when you're dealing with fractions, you know, common denominators, you have to figure out, like, okay, what can I do to the 1 to be able to, you know, 2 can't go into 3. So I can't do anything to the 2 to equal it, to make it equal to a 3. We can't use partial coefficients. Like I can't multiply it by 1/2 or 1.5 or something like that. We can only use whole numbers, okay? So I'm going to go ahead and put a 2 here to turn that into 6. And I'm going to put a 3 there to also turn that into 6. Okay? But I can't forget about my aluminum. Putting this 2, change this to 4 aluminum. Stick with me. I know. Don't let your heads explode. So I simply just have to come back and let me hope that I have the pen there. And put a 4 in front of that. No, where's the pen? There we go. Now it is a balanced equation. Okay, I have the same number of oxygen and aluminum on both sides. Notice I didn't change any of the subscripts, just the coefficients. Okay, let's do a couple more. All right, so hydrogen, I've got 1, 2. Remember how I said the capital letters? Whenever you see a capital letter, you know that's the start of a new element, okay? So I've got oxygen and hydrogen right next to each other. So I have 2 hydrogen. Chlorine is a tricky one. that's a C, lowercase l, it's not an I. So I have one of those. I have one sodium, and I have one oxygen. So 4 elements on that side. I'm going to have those elements on the other side. Over here, I also have 2 hydrogen, all right? I also have 1 chlorine. I also have 1 sodium, and I also have 1 oxygen. Well, what does that mean? It means that this is already balanced. We don't have to change it at all. But until you kind of verify that, you got to double check. So that's totally balanced. All right, last one is a little trickier, a little more complex. This is actually the formula for photosynthesis, okay? So we're told to do hydrogen and oxygen last. So I'm gonna look at my carbon, but I'm gonna go ahead and list out everything I have on each side. So on this side, all right, on this side I have 6 carbon. I have 12 hydrogen, and I have 8 oxygen because it's in 2 spots, okay? Over here, I only have 1 carbon. I only have 2 hydrogen, and I have 3 oxygen, which is weird, but they're in 2 different spots, so it's not as difficult to deal with as you think, okay? So I'm going to put a 6 right here, because that right away balances my carbons, okay? I knew I had 6 on the reactant side, now I have 6 on the product side. But by putting that 6 in front of that, it's also going to alter the number of oxygens I have, okay? I now have 12 oxygens right there, plus this 1, so that gives me 13 oxygens, okay? My hydrogens are still out of whack, and my oxygens are still out of whack, so I'm gonna deal with the hydrogens first, okay? Since I have 12 on the reactant side and 2 on this side, I'm gonna put a 6 there as well, because that will balance out my hydrogen. My oxygen is all messed up, so it doesn't matter if I keep changing the oxygen, okay? It's actually a good thing that I changed the oxygen. So in addition to the 12 I had, now I have 6 more. So that gives me a total of 18 on that side, okay? If I come back to the reactant side, how can I change that? My carbon is balanced, my hydrogen is balanced, so I hope that I don't have to put anything there, okay? I know that there's 6 oxygen there already. What can I do to this to come up with 12 more that I need to make 18? Yep, put a 6 in front of it. And now it is a balanced equation, okay? That gives me a total of 18 on that side as well. The 6 here and the 12 here. Boom, balanced. I know Khan Academy has some tutorials on this. There's some examples in the book. Spend some time on this. It is an important skill. I know it is tricky. Come to office hours and I can go through some additional examples with you if you would like, okay? Stick with it. I think that's all. Talk to you guys later.